For this graph, we're going to fill in the information and use all that information to graph. We have negative 2x cubed times x plus 2. First thing we're going to find is the zeros. So we have the correct number of blanks provided here to find the zeros. The negative 2 out front, that part is not going to give you a 0, but the x cubed part will. Again, you can imagine just taking negative 2x cubed, setting equal to 0. If you divide both sides by negative 2, you'll get 0. Take the cube root, get 0. So 0 here for that one. Take x plus 2, set it equal to 0, and we get negative 2 when you subtract 2 from both sides. For the y-intercept is when x equals 0. So for x equals 0 here, we put that back into the original one. So y equals negative 2 times 0 cubed, 0 plus 2. And because we have a 0, 0 times anything is 0. So all that cancels out, and I just get a 0 for that. So y-intercept would be 0, 0. So I know that's going to go through the origin, which makes sense because our x-intercept is also 0. So 0, 0 is both an x-intercept and a y-intercept. So I do know for sure that the graph is going to cross through right there. It also crosses through at negative 2 based on this. So now let's fill the rest of the information in. Multiplicities will be the powers attached to each of the factored pieces where you got the 0 from. So for this, the 0 came from this first term, and there's a cube there. So multiplicity is 3. And this one, there's no power on that. Multiplicity is 1 because there's no number there. That means it's you can always write something written to the power of 1. If multiplicity is odd, it crosses. If multiplicity is even, it touches. So in this case, both of these multiplicities are odd, which means it's going to cross at 0 and at negative 2. The degree you can find by adding up the multiplicities. So if I add the multiplicities, I get a 4. The max number of turning points is always going to be 1 less than your degree. It's that formula n minus 1 that we're using here. So 4 minus 1 will give us 3. For this one, the graph behaves like, we can actually figure out what the leading term is, because for this particular graph, we can multiply that out. So let's multiply this through. You get negative 2x to the 4th, and then minus 4x cubed. So from here, we see that the first term, the leading term, is going to be negative 2x to the 4th. And that would be what our answer is for what the graph behaves like. So we now want to talk about end behavior before we graph this, because we're going to use end behavior in order to draw a sketch. We have to know whether the graph comes in from up above or down below. So that's what we'll do first. Now, end behavior, we have to look at the degree. The degree is n. In this case, n is even. And then the number that comes in front of the x with the highest power, that's what the a of n value is. We look at this that we found earlier, the leading term. It's the number in front of the x that has the highest power. That's what your a of n is. In this case, it's less than 0. Now for that means that the graph is going to be going down for those. Okay, so we have it going down and going down there. So that's what we're going to do on this one. So first of all, I know the graph is going to have to come up from down below. So it's going to, because our end behavior says so. Now at negative 2, it crosses at that point. So I know that the graph is going to go up here, up to a certain point, and it's going to curve, and we have to have it go back down through the 0 here. Now, because there's a cube that's here, when it crosses at 0, it's going to resemble a cube. And a cube is going to be a graph that it kind of does this. It's got a bend in the graph. So whenever you see a cube, you want to make sure that you draw it correctly. We don't want to have it just go straight through, because straight through would be like a line. Okay, and that's kind of what this other one did over here, because this is a line where it crosses at -2. Where it crosses at 0, that came from this first piece, and that first piece is a cube. So I have to make sure that I draw it as a cube when it goes through like that. And of course, this will keep on going down because of the end behavior says so here. So we have a graph where both of them goes down, but again, this spot at 0, it's got to resemble a cube. It's got to have that bend in the graph, and that's what your overall graph will look like.